Okay, this should be a quick one. I know I say that a lot. But what we're going to focus on in this section, it says other methods of integration, and there are other methods. There's numerical methods that we actually don't have time to go over in this class, but the one thing I didn't want to touch on is just the table of integrals, because it can be useful for us, eventually. Just if we're dealing with something quite complicated, we're going to be integrating a lot in this class, and so we have been the whole time. You're going to do it in Calc 3, you're going to do it in differential equations, so sometimes just a good old table of what to do is going to be helpful. So I'm just going to do some examples. I want you to use the table that's in the back of the book. It's like those last few pages in the back of the book. Every time you do an exercise, or an example, I want you to state the number, and you can see how I do it on the fun sheet also. State the number of the integral that you used from the table. So let's just start off kind of with a simple one. So let's look at something like this. X squared square root of 4 minus x squared. Now, if I were to actually do this without using the table, I am going to probably do like a trig substitution or something like that, or I could even maybe try to use substitution. But we're going to do the table instead. So I have the table here. Let's see if this is going to work. And what I want you to notice on the table, hopefully you can see this, is that the table kind of gives you hints as to where you're going to find kind of what you need from the table. Okay, so I have my basic integrals right here. Those are kind of the main ones that you should know from 8.1. We have the trigonometric integrals. Sorry about that ink spot, my scanner. So any ones involving like your regular trig functions, two different exponents and stuff, you're going to find there. And then the hardest thing about doing tables is figuring out which one it is, because there's a lot of different formulas here. These are the reduction formulas for trig. So I'm going to skip all of this trig stuff, and I'm going to come down and look at these integrals involving. And so this gives you a hint of what your integrand is going to involve. So integrals involving, this says a squared minus x squared. Well, that's what we have over here, right? Over here we have 4 minus x squared, which is basically the same as a squared minus x squared. If this had been x squared minus a squared, then I would have gone down here to this x squared minus a squared part and had looked down here. But for right now, we're going to be looking in this section, right, of formulas to try and figure out how to do this one. And I see right away after I've highlighted this, what do I have along with it? I have the square root, so I want to look at one with the square root, and then I have an x squared term out front. So it looks like my winner in this case, hopefully you can see this, is going to be that 64 right there. Okay, and what I like to do, so I'm going to state, and let me zoom in on that a little bit. Maybe it's just me. I'm just getting old, huh? Don't tell me that. Don't tell me that. All right. Oh, sorry about that. I don't want to pay for the PDF. So I'm going to use number 64. So I'm going to put here, I'm going to use number 64 of the table. Okay. And what do I know here? What I like to do here is I like to tell myself a couple things. I'm dealing with x squared, so I'm going to deal with x squareds. And then a in this case, right? What am I squaring to get 4? It's 2. So that kind of helps me know kind of where to go from here. So what is this whole thing going to equal? Well, I mean, you can see what we're going to do. We're going to do x over 8. I'm just going to copy down what's going on here. And then we have 2x squared minus a squared. Don't put a squared though. What is a squared? It's 4 because my a is 2 times the square root of 4 minus x squared, right? And then I have, to give myself more room, and then I have plus a to the 4th, so 2 to the 4th is 16, I believe, all over 8. Ooh, that means I'm going to have some simplifying to do, but I'm not scared. Sine inverse of x over 4, x over 2, excuse me, plus c. Obviously, that's the antiderivative, right? No, not obvious. Not obvious at all. So I'm going to rewrite this, x over 8 times 2x squared minus 4, square root of 4 minus x squared. 16 divided by 8 is 2. Sine inverse x over 2 plus c. And it looks like that, with that sine inverse, that's going to kind of indicate to me that there was probably some sort of trig substitution that we used for that one. Now I don't know how to unhighlight it. Oh well. All right, let's look at another one. Let's look at one maybe that involves a little bit more work with it before we actually find the actual antiderivative itself. So what about something like, I want to pick one that's kind of interesting. What about something like this? Sine inverse of x to the negative 2 all over x cubed dx. Okay, so if I look at my table of integrals, I have an inverse sine function. So I'm going to kind of scroll through my integrals here, and I'm going to see if I see a sine inverse anywhere. I don't really have a sine inverse in my, oh, here we go. Here's my sine inverse. So there are a couple things that you can look at. Now notice, this is sine inverse of x, right? So I'm looking at this number 16 right here. I don't want to, don't do that. So number 16, but notice I need, I'm not taking the sine inverse of x, right? I'm taking the sine inverse of x to the negative 2. So this is an example of where I'm going to have to do a little bit of work before I can actually use my table. So what I'm going to do, I'm going to try u substitution. I'm going to let u equal x to the negative 2 because that's what I want to take the sine inverse of just one thing, right? I don't want to take the sine inverse of something raised to a power. I just want to take sine inverse of something. So in this case, it's going to work out pretty well actually, because notice the derivative of u, right, is a negative 2 x to the negative 3. Well, my friends, that's what we have right here, right? If I rewrote this integral, this would be the same as sine inverse of x to the negative 2, right, times x to the negative 3 dx. Well, that's pretty great because now I'm going to have a pretty nice, substitution here. Good. So what does this become? Well, I just want x to the negative 3 dx, right? So that's a negative 1/2 du. I don't know if you can hear that thunder. That is so cool. We don't get thunderstorms very often in Wyoming, but that's great. So I get sine inverse. Oh, I have that negative 1/2. I'm going to get a negative 1/2 integral of sine inverse of u du. This is great because now I can come over and I can use this number 16, right here. I can use that number 16 to evaluate. So what is my, now remembering though, instead of an x there, I'm going to put a u there, and then I got to bring my u back in. So I have a negative 1/2. Now notice there's more than one term, so I have to use parentheses. Instead of having x, I'm going to have u. So I'm going to have u sine inverse of u plus the square root of 1 minus u squared all plus c. Now that 1/2 doesn't have to multiply by the c. We could just kind of absorb that negative 1/2 with the c. And then my final answer then, sorry, I maybe should have practiced this a little bit before I actually recorded this with the table, but all right, so I get a negative 1/2, and then what is u? U is x to the negative 2. Sine inverse of x to the negative 2 plus the square root of 1 minus x to the negative 4, right? Because 2 times negative 2. We multiply exponents when we raise an exponent to an exponent. And that, my friends, is the whole thing. That's it. Isn't that great? These are pretty fun, don't you think? I like them. Okay, one more just because that was pretty fun. I just want to do one more where we have to do a u substitution because I like doing them. And you know what? I'll do what I want on this video. And if you don't like it, you can turn it off. Just kidding. I mean, I'm not kidding. You really can turn it off. Let's look at something like this. All right. All right, I'm definitely going to have to do substitution. You can look through the table there and you will see that you will not be able to find a table that has secant squared, tangent squared all over the square root of 9 minus tangent squared. But, you know, I know the derivative of tangent is secant squared, so it looks like a substitution that would make sense is u equals the tangent of theta. Guys, this is the last one I'm doing. I told you this was going to be a short one. Didn't I say that? I believe I did. Tangent of theta. What is du? Its derivative is sitting right there all nice and pretty. It's a little present just for me. Aw, you shouldn't have. My sister when she gets me presents, she now Googles math jewelry on Etsy. And I have like, I know that you guys probably don't care, but I have the coolest math jewelry. I'm wearing a necklace right now that is a Mobius strip. I love it so much. I love it so much. So notice the secant squared d theta, right? That's going to be replaced with, whoops, I don't need to search. That's going to be replaced with du. And then this tangent and this tangent was just replaced with u. So now we're raring to go. So this is du right here. So now I have to figure out what one this is. So it looks to me like this is another example. Maybe I should have thought about this more, but this is another example of a squared minus x squared, except of course, instead of x, we're going to have a u. So let me go down and find that a squared minus x squared. And now instead of having x squared times that square root, I have x squared divided by that square root. So let's see if I can find it. Oh, there we go. I think we have a winner. Looks like to me number 73 is going to be our winner. So this, and I need to, let's put that somewhere. This is number 73. I think I forgot to do that in the last one, but and where a is going to be equal to 3. And then sometimes I'll just say to myself, okay, and x in this case, remember, Sarah, that x is u, it's not x. Okay, so let's go ahead and do this. So a squared, that's going to be 9 halves. So I'm looking at number 73 over here. Natural log of absolute value u plus, I'm on the wrong one. See, guys, this happens even to the best of us. This should be number 66. My fault. My fault. How embarrassing. Do you hear that thunder? That is so great. All right, so number 66, my fault. So actually, what I'm going to have is a negative u over 2. Now we're good to go. How did I know I made a mistake? So this is a good learning experience, right? Well, I would expect my answer to have something like 9 minus u squared as opposed to I was getting u squared minus 9. That doesn't make sense because that's what I started with the opposite. So I said self doesn't make sense. And I am not too big of a person to admit when I'm wrong. Don't tell my husband that. But I can admit when I'm wrong. It's good for you guys to see me make mistakes. Is it embarrassing? Sure, of course. All right, and then finally, what is my u? My u in this case is tangent of theta. But you know what? You kind of get over that as you get older. So I'm going to have 9 minus, you don't get over the joy of math, of course, but you get over making mistakes. And then plus 9 halves or 4.5, whatever you want to do there. But I'd prefer probably a fraction. Sine inverse of the tangent of theta all over 3 plus c. Wow. Aren't you glad that some of these we don't have to do by hand? I know I am. I'm thankful for the table of integrals. Anyway, table of integrals, good way for you to get some practice just kind of rewriting integrams, working with some of the way that the table works with the different letters and numbers. And make sure on the quiz and stuff, if you use the table, when you use the table, that you go ahead and mark the number that you're going to be using on the table. I told you that short and sweet, you guys. 13 minutes, almost 14 minutes. I hope you enjoyed it. Let me know if you have any questions.